At Electron Energy Corporation, we specialize in rare earth magnets, magnet design, and magnet assemblies for customers around the globe. From our DFARS compliant and ITAR registered US-based facility in Lancaster, Pennsylvania, we produce samarium cobalt magnets, neodymium iron boron magnets, and magnet assemblies for applications that demand the most rigorous performance standards. EEC magnets and assemblies enhance technologies in the sky, on the land and water, in outer space, and deep below the surface of the Earth. Our magnets are used for military electronic warfare capabilities in sophisticated jamming aircraft like the EA-6B Prowler, advanced fighters like the F-22 Raptor, and the latest weapon in the US arsenal, unmanned drones like the Predator. They're also used by the US Navy in nuclear submarines that patrol the world's oceans for months at a time without surfacing, and as part of the powerful Aegis combat system to track and guide weapons to destroy enemy targets. In oil exploration, our magnets offer high precision to meet the rigid requirements of analytical instrumentation. Electron Energy helps companies search for oil miles deep into the Earth. And for satellite, wireless, and internet communications, Electron Energy magnets are a key part of critical hardware that keeps communication humming around the globe. So what makes EEC the world's leading magnet producer for all these applications? The answer is our uniquely deep expertise and a vertically integrated manufacturing process we developed over the course of 40 years. It's a process that gives us the ability to precisely control material compositions and give you the exact magnet you need. Let's see how we do it, step by step. It all starts with raw materials. We purchase and carry inventory of pure metals for the production of samarium cobalt 1,5 and 217 alloys from the best sources around the world. Using an induction melting furnace under an inert gas atmosphere, we alloy these raw materials and set their initial chemistry. Precise control of factors like temperature and atmosphere allows us to produce rare earth alloys, also called intermetallic compounds, with the widest range of magnetic properties available. Next, processes like crushing and jet milling reduce particle sizes to as small as 3 microns, the size of a single crystal. The particles are now small enough to be magnetically aligned and thermally densified later in the process. If the milled particles are too large or not uniform, the magnet will never achieve its desired magnetic properties. Once correctly sized, we can then precisely blend specific intermetallic compounds to formulate the final chemistry of your magnet. Uniformly distributing these compounds throughout the mixture is critical to creating high-performing, reliable magnets. After blending, we press the powder under high pressure and in a magnetic field to orient the magnetization direction of each particle. This allows us to achieve the full benefit of magnetic saturation later on in the process. Pressure is applied axially or transversely to the magnetic field, or isostatically, depending on requirements. Next, the pressed block, also called a green compact at this stage, is densified through a series of thermal processing or heat treating steps performed in the presence of a vacuum or an inert gas. Also called sintering, this process shrinks the green compact by as much as 25% and freezes the grain structure to achieve a state called radically uniform homogeneity. This final state is what gives our magnets the highest energy performance in the world. Machining shapes the magnet to its final dimensions. Because of their brittle nature, sintered rare earth magnets must be carefully machined using advanced techniques like grinding, slicing, and wire EDM. Otherwise, defects like breaking, chipping, and stress fractures can occur. Finally, the machine part is magnetized using a capacitive discharge process. In a matter of milliseconds, the magnet is fully saturated. After magnetization, stabilization occurs, and properties like maximum energy product and residual induction are tested to ensure compliance to your requirements. Special requests like flux testing can also be performed, and custom fixtures created if needed. At Electron Energy Corporation, our vertically integrated manufacturing process allows us to push magnet technologies to the extremes of temperature, stability, and engineered performance. And to make sure you get the exact product you need, our extensive design services uses 2D and 3D finite element analysis to solve the most demanding engineering problems. We work closely with you, becoming a virtual in-house resource for prototype design and fabrication. Find out how we can provide solutions to your demanding magnet challenges. Call today or visit us at electronenergy.com. Electron Energy Corporation, magnet experts from beginning to end.